Welcome. Today, we're diving into the powerful world of Postgres or recursive queries. Let's start by understanding what these queries are and why they are so useful. A recursive query in PostgreSQL allows you to query data with a hierarchical or self-referencing structure, much like traversing a tree or graph. Their main purpose is to explore relationships where the number of levels is unknown or variable. Think of organizational charts or product components. Let's break down the process using a simple analogy. Imagine finding all your ancestors. You start with yourself, that's the anchor. Then you find your parents, then their parents, and so on, until there are no more parents to find. This looping is the recursive step, and the stop is the termination. A recursive query in SQL follows this same logic, built within a with clause, also known as a common table expression or CTE. The anchor member is your starting point, a non-recursive select statement that runs once to establish the initial set of rows. The union ALL operator connects the anchor and recursive results. The recursive member refers to the query's own name, taking previous rows to find the next level of related data, looping until no new rows are found. The special keyword to initiate a recursive query in PostgreSQL is with recursive. This clause consists of the anchor member, the union ALL, and the recursive member. The query automatically stops when the recursive member yields no new rows. Here's a look at the basic SQL structure you'll use. A classic application of recursive queries is in supply chain management, specifically for a bill of materials or BOM. A supply chain manager needs to know every single component required to build a final product, like a bicycle. You can't use a simple join because the hierarchy depth is often unknown, making it inefficient for complex, multi-level structures. Consider a bicycle that needs a frame, wheel assembly, tires, spokes, and rim tape. We need a complete list, down to the smallest part. Here's a sample parts table and the SQL query to find all components for a bicycle. The query adds a, quote, level column to visualize the hierarchy, joining the parts table back to the CTE to find all children. The result is a complete, exploded bill of materials. Recursive queries are invaluable for any hierarchical data. They simplify tasks like building organizational charts, categorizing products, or mapping complex shipment routes.